Next, we're going to talk about the man-made nanomaterials. As the name suggests, man-made nanomaterials are nanomaterials that are produced by all human activities in the world, whether it is intentionally or unintentionally produced. We might think that the creation of impressive man-made nanomaterials, such as this quantum coral, which consists of 48 iron atoms positioned into a 14 nanometer circle, are only enabled since 20th century by the development of modern technology, and it sounds like it should be a profoundly modern concept, right? But however, when people study artifacts from ancient history, they are shocked when they found out that some of them are made of composite consisting homogeneous distribution of nanoparticles. There are many relatively famous examples of ancient artifacts which were created using nanomaterial. The first is Damascus steel swords from the Middle East, which were made between 4th and 70th century, are known for their impressive strength, shatter resistance, and exceptionally sharp cutting edge. The steel blades in fact contain oriented nanoscale wire and tube-like structures, which almost certainly enhance the material properties. Another example is Lycurgus cup. It is a 4th century Roman glass cup made of a dichroic glass that displays different colors. It turns red when light passes from behind and turns green when light passes from inside the cup itself. Recent studies found that the Lycurgus cup contained silver and gold alloy nanoparticles, specifically with a ratio of 7 to 3, in addition to about 10% of copper. It is made of a glass that changes color when light shone through it, and the glass is intentionally designed so that the body of King Lycurgus on the wall of the cup actually displayed slightly different red colors compared to the rest of the wall of the cup. Another example is the corrosion-resistant pigment known as Maya blue, which is first produced in the 3rd century, and it was discovered in the pre-Columbian Mayan city of Chichen Itza. The researchers start to study this because of the painting are unaffected to age, acid, weather, and also even modern solvents. It is actually a complex material containing clay with nanopores into which indigo dye was combined chemically to create an environmentally stable pigment that is preserved until this day. The pigment also allows them to produce painting with a special brightness and a single color that can range from a bright turquoise to a dark greenish blue. By clever technique, they are also able to produce Maya yellow, yellow color, by introducing different compounds into the pigment. The next example is the pottery and the cathedral glass from the across Mediterranean world, which is within 30th to 70th century, and it was often decorated with a metallic glaze called luster, which can be in different colors because of the special properties of nanoparticles such as gold, copper, and silver. And another astounding example of the ancient nanotechnology is Ayurvedic Bhasma, which is the ancient Indian nanomedicine. A Bhasma means an ash obtained through incineration. The starter material, which are horns, shells, feather, metallic, non-metallic, and herbals, undergoes an elaborate process of purification and eventually creating a biologically produced nanoparticle. This Bhasma is still being practiced in India and other parts of the world. Up till this day, we still don't know how they are able to produce those nanoparticle containing artifacts, especially without the knowledge of modern nanotechnology. These artifacts are without a doubt indeed intentionally or purposely produced to take the advantage of the remarkable properties of nanomaterials. The details regarding these ancient artifacts can be found in the interactive image in this section. Man-made nanomaterials can be classified into two categories. The first is the incidental nanomaterials and the second is engineered nanomaterial. Incidental nanomaterials are nanomaterials that is produced without the explicit intention to produce a nanomaterial, and they can be in the form of byproduct of mechanical or industrial processes. For instance, sources of incidental nanoparticle include vehicle engine exhaust, welding fumes, and combustion processes. For example, in this picture here we have silver nanoparticle which are released by the fork, which are released by a silver fork. The formation of silver nanoparticle might occur when common silver objects such as jewelry, silver wire, silver spoon, and forks were exposed to humid conditions. This stems from two main reasons. The first is due to its small particle size and enormous specific surface area. Therefore, it will contribute to rapid dissolution of ions than the equivalent bulk material. Second is due to their capacity to absorb biomolecules and interact with biological receptors. Therefore, it can be easily released from the metal bulk, unlike any other metals, towards the surrounding environment. Another example of incidental nanomaterial is microplastic and nanoplastic in our oceans. This is a hot, alarming issue related to the environment and concerning human health. When we use our car, we actually has released plenty amount of incidental nanomaterials in the form of platinum nanoparticles from the catalytic converters, as well as abrasion of the tires, the combustion process inside the engine, which all yet slowly but continuously affect our environment and eventually also our health. According to estimation by Hochschild in 2019, 1 to 10 ton per year of incidental nanomaterials are formed and delivered to the atmosphere. These incidental nanomaterials often comes with various shapes and sizes as shown in here, and often are poor quality and purity. Therefore, in most cases cannot be exploited for other application and are not recyclable. As opposed to incidental nanomaterial, we also have engineered nanomaterials, which are nanomaterials that are intentionally produced with the purpose to have a certain set of properties to be used for various human applications. So therefore, it is more well-defined object at the nanoscale in terms of its size, shape, purity, and etc., as can be seen in here. We can have a precise control on the composition, shape, and size distribution of the particle. So we have this stick-shaped, dice-shaped, pyramid, sphere, and many more. These engineered nanoparticles can also be functionalized with some polymer to add in unique properties. For example, functionalized gold nanoparticle for drug delivery application or biosensor, etc. We can also produce core shell structure, for instance gold nanoparticle coated with a silver layer. This will extend the tolerability or tunability in the properties of the nanomaterials. Unfortunately, it is estimated that 1 ton per year from engineered nanomaterials make their way into the environment, mostly through wastewater treatment plants, holding ponds, and landfills. Finally, we're going to talk about nanomaterial cycle of the Earth. Like water and rock cycle of the Earth, recently scientists has established the nanomaterial cycle of the Earth that helps to explain how the Earth works as an overall system. There are 3 parts or 3 stages of the cycle, which are: the first is the Earth components, second is the nanomaterial precursors, and the third is the nanomaterials itself. The dynamic and interaction between these 3 parts of the cycle can be illustrated in this figure. The cycle can begin from nanomaterial precursors, which forms nanomaterial through various types of chemical interaction. This nanomaterials growth or production, whether it's through natural processes or human activities, are essentially very complex and often irreversible. When the reaction does proceed to nanomaterials, the growth may continue to a bulk material, or it might stop in the nanoscale domain depending on the interaction of its surrounding. The precursor may originate from the earth components such as soils, watersheds, continents, through the process of weathering, or also in the form of human-dominated components or activities such as mining, factories, farm, etc., which are usually irreversible process. The various nature of the process actually produce enormous variety of fundamental chemical components. The cycle is completed through the reversible connection between the earth component and the nanomaterials due to weathering, biological processes, and also human promoted breakdown of bulk material into nanomaterials, which we call it top-down processes. In the next section, we're going to talk about the emergence of nanomaterial. Thank you for your attention.